Welcome to this video. In this video we are going to discuss about the statistics. Statistics is a branch of mathematics that deals with the data analysis or collection of data, organization, interpretation and presentation. In applying statistics to scientific, industrial or social responses, it is begin with the conventional method, that is statistical method. Begin with the statistical population are to be studied. Statistics deals with the all aspects of data handling, including the data collection and planning, development of this status samples. Statistics with all the aspects of including collection of data and planning, and we deal with this aspect to the design of experiments and survey of samplings. Two main importance of statistics: one is descriptive statistics, second one inferential statistics. We have two approaches. The first one, descriptive statistics, which summarizes the given data and analyzing that. Descriptive statistics most often we used in distribution, that may be sample and population of statistics. Inferential statistics, which draw the conclusion from the data analysis concerned with the random experiment. Now we are going to discuss about the testing of hypothesis. Before that, we want to know some basic definition of sampling. Now we are going to discuss about the testing of hypothesis. The first one is population. Population means it's a group of individual collection of data. That is a group of individual collections. A population consists of collection of individual units, which may be a person or experiment outcomes whose characteristics are to be studied. Population means group of individual, that is the collection of individual units of a sample. Okay, for example, we have the population of products turned out by a machine, or another one is population of live electrical bulbs manufactured by a company, that may be finite or infinite. Next one is sample. Sample is a collection of, next one, sample. Sample is a portion of population sample. Okay, that should be studied to learn about the characteristic of the population. That is, a finite subset of individuals in a population is called sample. A finite subset of individual is called a sample, and the number of samples are called the sample size. Always the sample size is denoted by the letter small n. A numerical measure of a population is called population parameter, or simply it is called an parameter. A numerical measure of the sample is called sample statistic or statistic. That is, a numerical measure of population is called population parameter, or another hand, the numerical measure of the sample is called sample statistic, or simply it is called a statistic. Next one, random sample. A random sample is one in which each item of a population has an equal chance of being selected. Next one, sampling. It is a process of collecting a sample from the sampling. That is a population mean. It is called sampling. The standard deviation of the sampling distribution of a statistics is known as standard error. Sample sizes, the number of items selected in a sample is called sample size. Always it is denoted by the letter n. Depends upon the size of the sample, we want to classify into two categories. One is large sample, another one is small sample. If n value is greater than 30 means that is comes under the large sample, less than or equal to 30 means that comes under the small sample. Or if n greater than or equal to 30 means large sample, and n less than 30 means we call it as small sample. Sampling distribution. The sampling distribution of a statistic is the distribution of that statistic. Consider all the sample size of n drawn from a given population sample at random. We calculate mean values of these samples. If we group these different means according to their frequency, the frequency distribution is so-called sampling distribution. It may be considered as the distribution of the statistic for all possible samples from the same population of the given size. The standard error, the standard deviation of the sampling distribution is called standard error. Statistical hypothesis. A hypothesis is an explanation for a phenomena that can be tested in some way that ideally either proves or disproves. Under statistical hypothesis, we have two cases. One is null hypothesis, another one is alternative hypothesis. The hypothesis is tested for possible rejection under the assumption that it is true. That is usually called as null hypothesis. The null hypothesis is always denoted by the letter H0. And alternative hypothesis, which reflects the situation anticipated to be correct if the null hypothesis is wrong. Alternative hypothesis is always denoted by the letter H1. Level of significance under testing of hypothesis. We have two categories. One is 1% level, another one is 5% level that should be used in sampling. It is the probability level below which null hypothesis is rejected. Generally 5% and 1% level of significance are used. Under the level of significance, we have two cases. One is critical region, another one is rejection region. The region corresponding to the test statistic in a sample space which tends to the rejection of H0 is called critical region or rejection of region. The region complementary to the critical region is called region of acceptance. Okay, we denoted the alpha, the probability representation, the probability of making type 1 error, that a random value of a test statistic belongs to the critical region is known as level of significance. The level of significance is the size of type 1 error. Already we discussed the level of significance. We have two cases. One is 5% level, another one is 1% level that should be employed in the test statistic. The level of significance is always fixed in advance before collecting the sample information. We had two types of tailed test, one tail and two tail test. Basically we have three kinds of there are three kinds of test under hypothesis. They include two tail test, right tail test, left tail test. If it is one tail test means only one tail of the sampling distribution of the normal curve is used. The test is described as one tail test. Here we assume the null hypothesis is mean values are equal, that is mu1 is equal to mu2, and formulated the null hypothesis either mu1 is greater than mu2 or mu1 is less than mu2. Critical values or significant values. The value of the test statistic which divides the critical or rejection region and the acceptance region is called critical value, or otherwise it is called as significant value. It depends on the level of significance and test statistics value. Here for example we have large sample test statistics for mean is it equal to t minus e of t divided by standard error of the function t. Okay. Under large sample test we are going to use the normal table or normal curve mean with respect to mean and standard deviation as n tends to infinity. The value of z given by above the under null hypothesis known as test statistics. For large sample test we have the following normal table value. The critical value of Z are commonly used level of significance for both two-tail or single-tail test are given below using this normal probability table. For calculating the two-tail test, the right-tail test or left-tail test, for the level of significance 5% or 1% level, we are going to use this standard table, probability table here. That is critical value, level of significance for 1% level, 2% level, 5% level, 10% level is given here. Two-tail test, that is modulus of Z alpha, that is equal to 2.58 at 1% level, at 2% level is 2.33, at 5% level is 1.96, 10% level is 1.645. For right tail test means that the value is greater than mu2, that is mu1 is greater than mu2, we are going to use the right tail test value. At 1% level we have 2.33, 2% level 2.055, at 5% level we have 1.645, at 10% level we have 1.28. Next one for left tail test, here mu1 is less than mu2, then the corresponding normal table values for large sample. At 1% level we have minus 2.33, at 2% level minus 2.055, at 5% level 1.645, at 10% level we have minus 1.28. We have two types of errors, type 1 and type 2 errors. When a statistical hypothesis is tested, there are four possible results arises. First one, the hypothesis is true but our test rejects it. The hypothesis is false but our test accepts it. The hypothesis is true and our test accepts it, and the hypothesis is false and our test rejects it. Obviously, the first two possibilities leads to error. The first two possibilities leads to error. If we reject the hypothesis, then the result will be accepted. That is called type 1 error. We reject a hypothesis when it should be accepted. We say that the type 1 error has been made. On the other hand, we accept a hypothesis when it should be rejected. We say that a type 2 error has been made. In either case, a wrong decision or error in judgment has occurred. Type 1 error means rejection of null hypothesis when it is correct. Type 2 error is acceptance of null hypothesis when it is wrong. Here we have two types of testings, decision and acceptance of H0, rejection of H1 based on these two conditions. Decision is H0 is true, that is our null hypothesis is true. Corresponding condition, we accept H0 when it is correct decision. Reject H1, that arises type 1 error. Second one, the decision is H1 is false, that is our alternative hypothesis is false. Then acceptance, that is a type 2 error arises, rejection of H1 when correct decision. In practice, type 1 error amounted to rejection of lot when it is good, and type 2 error may be regarded as accepting a lot when it is bad. It is one example. Thus, the probability of reject a lot when it is good, that is denoted by the letter alpha, where alpha is the producer risk. Second one, probability of accept a lot. Second one, probability of accept a lot when it is wrong or when it is bad. That is denoted by the letter beta, that is consumer risk, where alpha and beta are referred to as producer risk and consumer risk respectively. Producer risk means reject a lot when it is good. Consumer risk means accept a lot when it is bad. Two-tail test, when two tails of the sampling distribution of the normal curve are used. The relevant test is called the two-tail test. The alternative hypothesis we formulated as H1 is mu1 is not equal to mu2 is taken in two-tail test for H1 is mu1 is the alternative hypothesis we formulated as H1 is mu1 is not equal to mu2 and we formulated as a null hypothesis is H0 mu1 is equal to mu2 in two-tail test. Okay, there is a normal curve for one-tail test. Okay, now the normal curve for one-tail test and two-tail test. For one-tail test, we have two cases. One is right-tail test and left-tail test. If it is we formulated as our alternative hypothesis is H1 mu1 greater than mu2 means in a normal curve, we draw the acceptor region and rejection region at a point z equal to 1.645. Under left tail test, the value is negative that lies on the left side of the normal curve. There is alternative hypothesis here we formulated as mu1 is less than mu2. Here z point is the minus 1.645. Therefore, at 5% level, the rejection region is the shaded area. For right tail, this is for left tail test. This region is acceptance region. In two-tail test, we formulated our null hypothesis both are equal and alternative hypothesis either mu1 greater than mu2 or mu1 less than mu2. Here at 5% level of significance we have the point, the standard value of our z is minus 1.96, the shaded area in left side. At z equal to 1.96 in positive level, that should be shaded in the right side. Okay. This 5% level 0.25 for, that is 0.25% for right hand side and left hand side. The remaining region is called our acceptance region. These two are rejected region. We have two types of samples, depends on the sample size. If the sample size n value greater than or equal to 30 means we use large sample. If n value less than 30 means we use small sample. If less than 30, then the sampling distribution of many statistics are not normal. So we have to develop entirely different tests of this significance based on t-test, f-test and chi-square distribution. Okay, if it is a small sample means the values are not represented in normal curve. So we can use the different form. The different form here we have t-test, f-test, chi-square distributions. For solving small sample problem, we want degrees of freedom. That is, if the number of degrees of freedom is always denoted by the symbol mu, the number of degrees of freedom is the total number of observation minus total number of independent constraint imposed on the observation. That is, if n is the number of observation and k is the number of independent constant, then n minus k is the degrees of freedom corresponding to the distribution.